All right, now we're going to do the integral of sine to the fifth power theta d theta, and like the previous one on the cos to the fifth power theta d theta, this is also done analogously and is not too difficult to evaluate, in fact. So here we go. We're going to write this as sine to the fourth power theta times sine of theta d theta, which then we will write as the integral of sine squared theta, and that we will itself square it to give back the fourth power times sine of theta d theta. And then we bring in our most famous of all trig identities, namely sine squared theta plus cos squared theta has to be 1. So the stuff in the parentheses is the integral of 1 minus cos squared theta, that expression is squared, times sine of theta d theta. And then we FOIL that out. So we get the integral of, in the parentheses I get 1 minus 2 cos squared theta plus cos to the fourth power theta times, on the outside we get sine theta d theta. And here, just like we did in the previous video, we say, okay, well, check this out. I can say that d, instead of d theta, let me say d of cos theta. We're using the chain rule here. Is going to be d, the derivative of cos is going to be minus sine theta times, now I have to do the d of the argument inside there, which is theta, so that's d theta. Okay, so okay, now I can say the following. I can say, therefore, if I bring the minus over here, I get minus d of cos theta is equal to sine of theta d theta, which is exactly the stuff sitting outside of the parentheses. Right, so if I bring that into bear, now we've changed our integral from, with respect to d theta, to d of cos theta. So I've got the integral, and again, that's perfect because look, everything in the parentheses is in terms of cos of theta. So 1 minus 2, I'll write cos squared as cos theta being squared, plus, instead of cos to the fourth theta, I'll write this as cos theta to the fourth power. And then, as we just said, this is going to be times minus d of cos theta. Okay, and so that minus just changes the signs on all of those terms. So I've got the integral of minus 1 plus 2 cos of theta squared minus cos theta to the fourth d cos theta. And this is an exceptionally easy integral to evaluate because everything's in terms of cos and we're integrating with respect to cos. So here we go. This is going to equal minus integral of 1 d cos theta is just minus cos theta, and then this is going to be plus 2/3 cos cubed theta minus 1/5 of cos to the fifth power theta, plus we pick up a constant of integration. And so we have shown that the integral of sine to the fifth power theta d theta is equal to all of this. And you can just compare notes between this video and the last video and see the analogies between the two. Okay, thank you for your patience and watching, and we will see you in a future video.